Hello and welcome back to part 7 of the Introduction to Calculus series. Today we're going to be talking about the derivative of exponents. So we're going to be talking about how to find the derivative of, say, 2 to the power of x. We already saw how to differentiate functions like x squared, where the exponent contains just a number, right? So 2 or 3 or negative a half, something like that. But we haven't talked about what happens when that x is in the exponent. So let's see what happens. Let's take a look at the definition of the derivative. So we'll actually look at this example, 2 to the x. So the definition of the derivative, if you remember from earlier parts, that's going to be f of x plus a tiny difference in x minus just the regular function, all divided by that difference. Right, like that. And we want to see what happens when the difference kind of approaches 0, gets really close to 0. Alright, so let's fill in 2 to the x for our function. So that's going to be 2 to the x, and then just plus that like that, and then just 2 to the x here, all divided out by, well, the difference in x. Alright, so what we can do actually now, so I'll manipulate this, because we can use the exponent. If you have an addition in the exponent, that becomes multiplication, like that. So you can split it up like that, and then just copy this. And now what we can do is we can actually factor 2 to the x, because we have 2 to the x here, and we have 2 to the x here. Right, so we can do something like this. That becomes -1, still divided out by delta x. And now we actually have, if I write it more explicitly like this, we have kind of that the derivative of 2 to the x is just 2 to the x times some constant, right? This is just a number that we can compute. And this number actually turns out to be a certain type of logarithm, but I'll come back to that. Because what we can try to do is we can try to find a base, right? A number in the base of our function. Let's say f of a to the x, where this constant is equal to 1, which would mean that the derivative of that function is actually, well, that's just going to be a to the x times 1, which is just a to the x. So the derivative of that function would actually be itself. So let's try to find that. So we'll set this, so I'll substitute a in for 2, so that we'll get a delta x minus 1 divided by delta x. And we'll set this equal to 1. And now we'll just solve for a. Alright, so we'll multiply out by delta x, and I'll actually add 1. And then we have to, well, then we'll just take kind of the delta x root like this, and that will give us a, or we can also say that a is the delta x plus 1, and then this is really the same thing, 1 divided by delta x, right? And this turns out to be, because you can compute this, right, if you go smaller, if you plug in smaller and smaller values for delta x, then you eventually get something like a is 2.71828, blah 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 blah. And in mathematics, this number is so important that there actually is a special name for it. It's called Euler's, I don't really know, Euler's number, or just E for short. E, that's called E. So anytime you see E, it's this number, and you'll see it often enough. It's used very often. It's a very important number in calculus, but also beyond. And so this number has the property that if you have a function f of x equals e to the x, then the derivative of that function is going to be, well, as we saw, that constant will be 1, so we'll get e to the x. Right, so the function is its own derivative. And the same obviously goes for the second derivative, that's also e to the x, and on and on and on. Now, right, so let's get back to how do we compute the derivative for, let's say, 2 to the x. Because we know how to compute it for e to the x. Well, that's easy enough. But how do we do it for 2 to the x? Well, here e also plays a role, because the derivative of 2 to the x, right, so we have 2 to the x, and then the derivative, as we saw from our derivation earlier, it's going to be some constant times 2 to the x. So what's this constant going to be? Well, this constant is actually log base e of 2. So you take the base of your exponent, right, of the function, that's going to be 2. That's the input to your logarithm, and the base of your logarithm is always e. So let's do another example to make it clear. If you have a function, for example, 3 to the x, and you want to differentiate this, so f of x, and then you want to differentiate, then you just copy 3 to the x, that remains the same, but you have to multiply by log e of 3, like that. And again, this logarithm is so important that it also has kind of a special notation. This logarithm is kind of most oftenly denoted as ln, or natural logarithm. So then you just say ln of 3, like that. So if you have, more generally, if you have a function, an exponential function a to the x, and you want to find its derivative, you multiply by ln of a, and then just the original function. Right? That wraps up the video. I'll see you in the next part. Bye bye.